So, I now welcome you all to the second session of units and measurements. We today are gonna speak about significant figures. So, this is what you are gonna learn today. This is all what you are gonna learn today. This is all from NCERT, and I suggest you to solve questions later related to this because this is one such concept which has got maximum doubts in the minds of the students while they solve the sums or numericals which is related to any other chapter. This is the basics, very basic concept which is must and should be known to every student. This is something which is gonna turn your MCQ, like if there are 4 options in the MCQs, then obviously of the 4, one or two might be of this confusion. That is, this is the topic which they, like, you can get MCQs based on this also. It is a normal MCQ of some electricity probability, and you will find the answers. But on seeing the options, you will find out, yeah, whatever option I have got is right, but there are 3 or 2 options which are matching my answer. Which one should I opt for? So then comes this concept of significant figures and rounding off. So this is a very much important concept where students will be having maximum doubts, maximum confusion, but this is a topic which you need to be clear thoroughly. So now welcome to this session. I will be clearing all the confusions off, like whatever you might be having, because NCERT statements are so clear. I'll be quoting the NCERT statements and be teaching you in this video. The thing is, after knowing this concept, I definitely recommend you to solve some questions, some numericals. Go through the NCERT examples. Go through the NCERT example sums. Then go through the NCERT exercise questions. Later, solve any of the reference books that you would want to. But this concept should not be ignored. This is the concept which you need to give maximum weightage for. So see, you can see I have the NCERT aside. I'll be quoting the important lines and I'll be teaching you in this video. So now coming to the topic of significant figures or digits. So according to that NCERT, there is one statement: the reliable digits plus the first uncertain digit are known as significant digits or significant figures. So why is that this discussion is out here? The thing is, when you measure anything, you will be measuring and giving some values. That measurement that you have given will have some number of digits. For example, in a normal meter scale, you can take any digit, point some digit. That is, you will give any measurement in millimeters. Like, as you know, 1 centimeter in that meter scale has 10 divisions. Again, least count problem will come here, and that is where the significant figures is important. So here you will be measuring things in millimeter. But if you're telling some measurement to be 1.55, then from where did you tell that extra 5? You're telling it based on just like that. So then that is an uncertain digit. It is not a reliable one. So the reliable digit plus the first uncertain digit are known as significant digits or significant figures. So according to this, there are many uncertain digits. Like, there can be many number of digits. The number can be 1.325, etc. Here you're considering only this much in the case of meter scale. So this is the first uncertain digit. These are any number of digits here will become uncertain, including this 3. So because that is the least count of the meter scale, 0.1 centimeters. So this first digit is the this digit is the first uncertain digit. So this reliable digit that you have, that is a centimeter measurement, and the first uncertain digit together is a significant digit or significant figure. You're neglecting these two, you're ignoring them off. So this is the example of meter scale. Do not get confused, this is only for meter scale, where the least count is 0.1 centimeters. Now coming to the rules of the significant figures. Before giving the rules, they have given one statement: a choice of change of different units does not change the number of significant digits or figures in a measurement. Example to quote, this 1.3 centimeters only can be written as 13 millimeters or point. So see here, you're changing the unit. Here there is no change in the significant figures. How will you tell this? For this you need the rules. So coming to the rules, non-zero digits, whatever are there, it is all significant. All the non-zero digits are significant. Matlab here 1 is a non-zero number, 3 is a non-zero number, all the non-zero digits are significant. Next, all the zeros between two non-zero digits are significant no matter where the decimal point is, if at all. This is the NCERT statement. What it means is 1003. Here two zeros are there in between two non-zero digits. So these two zeros are significant. If at all there is a decimal point here, or if there is a decimal point here, or there is a decimal point here, it doesn't matter, because those decimal points are there between two non-zero numbers, and these zeros are there between these two non-zero numbers. Wherever is the decimal point, it is significant. These zeros are significant. It can be even 0.1003, it doesn't matter. Can be 10003.0, it doesn't matter. Wherever is this decimal point, if at all, if it is present, then also all the zeros between two non-zero digits are significant. You're gonna consider them as significant digits. So there are two rules that we saw: non-zero digits are significant and zeros in between two non-zero digits are significant. Now coming to the next point given in the NCERT, if the number is less than 1, the zeros on the right of the decimal point but to the left of the first non-zero digits are not significant. You can see in this example where I have written 0.002308, here zeros are there to the right of the decimal point, no doubt, but it is before a non-zero number. So these zeros are not significant. Please do remember, these are the rules that are gonna help you out, and if you follow these rules, you're not gonna get confused. For not getting confused, only knowing the rules is not important. You must be knowing the numericals or some number examples. You need to solve as many numericals as possible. You need to see as many examples as possible. Then only you will register these things in your mind permanently. So if there are zeros after the decimal number, that is to the right of the decimal number, before a non-zero digit, that is to the left of the non-zero digit, then these zeros are not considered. They are not into the significant digits. You're not going to take them as significant digits. Next rule is that the terminal or trailing zeros in a number without a decimal point are not significant. So this is the number example I've taken, 1000. Here this 1000 has no decimal points. It is pakka 1000. So in this 1000, the terminal zeros, or also called as trailing zeros, they are not significant. It is a non-decimal number. So these three zeros which are there after a non-zero digit, the trailing zeros are not significant. They are not at all significant. So next, coming to the other rule, the trailing zeros in a number with a decimal point are significant. So this is a number 3.500. This is after a decimal point. So these zeros are significant. They are significant. It can be an example like 3.00. Here also these zeros are significant because they are present after a decimal point. So as I said before, change of units will not change the significant numbers. To avoid this confusion, you are gonna represent any digit or any number that you will get, any result, in terms of scientific notations. In the scientific notation means in the power of 10 to the power x. So this x here is called the order of magnitude. This x is called the order of magnitude, and that order of magnitude is not considered to be significant numbers. For example, some 4.7 meters can also be written as 470 centimeters. Also 4,700 millimeters. Here see, I'm giving you how many significant numbers. If you can see, this is 4 significant numbers here, but here, because you have changed the unit, the number is remaining the same. But if you see, this will also have 4 significant numbers because after a decimal there is 1 0, but here it is gonna be only 2 significant figures because you have changed the unit. This should not happen, and that is why you will write it in terms of order of magnitude, if you like, in the scientific notation, so that you will never miss up the actual significant digits. So to avoid this confusion of 4 and 2 significant digits, you will have to write this number in terms of scientific notations and put the units. So this change of unit should not be a problem. It is actually not a problem. A choice of change of different units does not change the number of significant figures in a measurement. So always have the habit of using scientific notations. And now you know what an example or a number is. Now how to use that in arithmetic operations, that is one thing which you need to know, because you will get confused here. There are these rules. In addition or subtraction, the final result should retain as many decimal places as are there in the number with the least decimal places. If you see here, I have written it in the short forms. Whatever I read now was the NCERT statement. This is a easy way to write it down. In addition and subtraction operations, the final result you get should retain least decimal places. Example, if you're gonna add these 3 numbers, the significant figure of this particular number here is 5, this particular number is 4, this number is 3, but you're not checking this significant digits at all in addition and subtraction. These are not at all considered. If you see, after the decimal point, this number has 2 digits, this has got 1 digit, and this has got 3 digits. So you are considering this 2, 1 and 3, the digits that are there after the decimal place. Now when you add whatever answer you get, you should keep it in terms of 1 decimal place only. This is the least decimal place, so you will keep it in terms of only 1 decimal place. The answer that you get, 0.1 decimal place should only be there. Now if you add this, okay, I know this is going to be kacha here if I write it here, so I'll write it here. 436.32, 227.2, 0.301. You will be getting an answer like this, but you are gonna keep only one digit after the decimal place. It is the least decimal places among the numbers that you are adding or subtracting. So you are keeping the least digit decimal place, so it is only 8 you are keeping. How can you keep only 8? If at all this digit was 5, then could you keep 8? No, it is yes, you could keep it as 8. Only if it crosses 5, if it becomes 6 or 7, then this 8 will not remain 8, it will become 9. I will come to this concept here in rounding of the uncertain digits. This is also something where a little confusion lies, but not as much as these topics. This significant figures is something that you will have to know properly. So here the answer is just 663.8, because the least decimal places, remember, in addition and subtraction, it is just the least decimal place that you are seeing. Only the least decimal place, the 3 numbers that you are adding, or any number of numbers that you are adding or subtracting. Now coming to the multiplication or division. In multiplication or division, the final result should retain as many significant figures as are there in the original number with the least significant figures. It simply means that there are some original numbers, among them which number has the least significant figures. That many significant figures will be retained in the final result. Of the original numbers, whichever has got the least significant figures, that many significant figures will gonna be there in the final answer or final result of that particular sum. So if there is multiplication or division of this to be happen, let us take division. So 4.237 divided by 251 will give 1.69. So this is an example that is given in the NCERT. I have the NCERT open in front of me, so I'm writing the values like that. So this is the 3 significant numbers are there, and here it is 4, and you have to keep the answer in 3 significant figures only, because that is the least significant figures that you have. You're not supposed to keep it very big. Okay, so sorry for this inconvenience of slipping, but still. So this is what you need to remember, the rules and the rules for knowing or writing the number of significant figures, and rules for the arithmetic operations. Next, coming to the rounding of the uncertain digits. This is one of the concepts that you need to know. Not so much. I have not taken the example of any number here. I have taken it in terms of xy.za. Just the indication. Now here, xy are pre-decimal numbers, za are after decimal. So significant and insignificant. What is that significant, insignificant, and uncertain? For example, think this is a meter scale case, and here these reliable number and first uncertain digit is gonna be significant. The further any digits which are uncertain is gonna be insignificant. So you got to know, no? Significant is the reliable digits plus 1, the first uncertain digit. So here, how will you round off this xy.za? If at all this a, you are gonna drop the insignificant numbers. In rounding off means you are gonna drop the insignificant numbers. So you just can't drop it like that. No, you need to check like what should be added to the previous number, the preceding number. So here, if this a is greater than 5, I've given here, if a is greater than 5, then z should be added with one number. But if a is less than 5, then z will remain z. It will not be added with any number. But if there is a case that a is equals to 5 then depends upon the z. If z is even, then you are gonna drop that a as such without adding anything for z. But if z is odd, then obviously, and a is 5. If z is even and a is 5, you are gonna drop a as such, z remains z. If z is odd and a is 5, then you are gonna add 1 for z before dropping a. This is something I can give you a numerical example. 135 is a number and 145 is a number. I mean 13.5, 14.5 and 13.6, 13.4. If you have to round this off to two significant figures, all these four numbers to two significant figures, okay, this number would become 14 because this 6 is greater than 5, but this number is gonna remain 13 only because 4 is not greater than 5. But here both the digits here, to round them off to two significant numbers, the third digit is 5. So now it depends upon the preceding digit. Here the preceding digit is odd. If it is odd, you need to add 1. So this is gonna be rounded off to 14. But here the preceding digit is even, so this is gonna be rounded off to 14 only. Matlab here you're not adding anything to the preceding digit, you're just ignoring this final digit. So now this is for the operations, these rules are, and for the result that you write also, these rules will hold good. What do I mean by telling results means? These things, that least decimal and least significant figures that you will concentrate on when operating plus, minus or multiply, division respectively, is that final answer, whatever you get, for that you need to apply these. If the final answer is addition subtraction, then least decimal places should be retained, least number of decimal places should be retained. If the final answer of a multiplication or division to be found, then it is the least significant figures of the original numbers, of the given original numbers, that should be kept in mind. Now there is one important statement the NCERT here has: intermediate steps. The intermediate result in a multi-step computation should be calculated to one more significant figure in every measurement than the number of digits in the least precise measurement. So simply, in simple words, in intermediate steps of a multi-step computation, keep one extra digit more than the actual significant digits, because this is the example that you will see, and this is the doubt that every student will get while solving the questions. So round off only the final answer, not in between. Example here, this is one number. The question is, you need to take the reciprocal of it, again take the reciprocal of the obtained answer. So if 9.58 is the number, if you take a reciprocal of 9.58, actual answer is 1.044. Now if you take the reciprocal of 1.044, you get 9.58. But if you round it off to three significant figures, because 9.58 has three significant figures, if you round it off to three significant figures, as in this case, then when you take the reciprocal of that three significant digit number, that 1 by 1.04, will result in 9.62, which is way different from 9.58. It is not same. So there will be building up of rounding off. This is what they give. The rounding errors can build up. So actually errors build up by doing this. You're not taking off the error. You're not taking off the uncertainty. You're actually creating uncertainty. So round off only the final answers, not the intermediate steps. So this is all for today. This is a very important concept everyone should be knowing. Don't mess up, practice well, solve the numericals, and you will find it out. When you see more examples and solve numericals, you will obviously be clear with the concept. So this is an important basic concept. This is a very basic concept which is very much important, because as I said, you numericals, not just numericals, to solve the numericals it will be helpful, but also to like you can actually clear some MCQs in the actual NEET paper where they concentrate on this. 1 or 2 MCQs, they concentrate on this concept actually. So this is important. You will be gaining some 4 marks. I am talking about NEET because I have given only NEET. I don't know what the JEE pattern will be, but the concept is well and good. It holds good for that also. So I'm including JEE people also here. You can also watch this, JEE aspirants. But NEET though I have given, and I'm sure 1 or 2 questions obviously, so 8 marks is in your hands. So all the best, prepare well, know the concepts well, understand and solve the questions. And yeah, like this video, subscribe to my channel, share as much as possible, because there will be many friends who might be in actual need of these videos, but it is in your hands to help them or not. So if you help them, obviously they'll be learning good. They will also remember you for this. It will be a very nice Thanksgiving, and it is a very good attitude to share things. So please do share the video, subscribe to my channel so that you will get the further notifications. Obviously you need to on the notification button, and please do like this video. Thank you all for giving me this confidence enough that I can teach some students at least. So all the best. Thank you.